The last section of the notes for chapter 4, continuing on for 4.4, heat and thermodynamics. So for this section, to end off of our chapter, I'm just going to go through the 3 laws of thermodynamics. They're pretty short and simple, and then we will be doing a review for the test on a Kahoot. And I'm actually going to record that for those of you that are remote, so you can kind of hear my explanations for each of the problems and the solutions to the problems. If you're in class, we actually played the Kahoot and reviewed together before taking the test. Okay, so the first law of thermodynamics is that energy is conserved. So the whole chapter that we've been talking about, especially in section 2 of chapter 4, was about conserving energy. So it can't be created or destroyed, but it can be converted. So if you remember back to like all of the pictures, okay, if you were in class, I assigned a picture to you to tell me how the energies are transforming, how they're being converted from one to another. So for example, the light bulb is converting from electrical energy into radiant or light energy. Okay. The second law of thermodynamics states that thermal energy can flow from low to high only if work is done on a system. Okay, so normally it's going to go from high to low. So if you think about your hand on the surface of the desk, okay, your heat is flowing into the desk, warming the surface of the desk. Okay. In order for it to go from low to high, so cooling things off basically, there has to be work done. So things like refrigerators or air conditioners, they're having to put in extra work in order to change the flow of the energy. Okay, and so with refrigerator systems, they have like compressors and things like that help to change the dynamics within the tubing that heat and cool things in order to force the heat to leave the inside of the refrigerator. Okay, so there has to be extra work done. That's why we have to plug it in. It has to get extra energy from electric energy. The last, third law of thermodynamics is that absolute zero cannot be reached. So if you remember, I kind of briefly touched on this in section 2 of chapter 4. So absolute zero is 0 Kelvin. So absolute zero just means that there is no particle movement. Okay, so if you remember, temperature is the measure of the movement of the particles. So the faster the particles are moving, the higher the temperature it has. If they're moving slower, it's going to have a lower temperature. So 0 Kelvin is if there is absolutely no movement. So it is theoretical. We have not been able to reach absolute zero. Okay, and that's statement of the third law of thermodynamics. If we are able to reach it, the third law would not apply anymore. Okay, so scientists have gotten really, really close. They've gotten 3 billionths of a Kelvin above absolute zero, which is very, very cold, but they have not been able to stop this completely. Okay, that is the end of chapter 4, so you will go and watch the review video and then take the test over chapter 4.